This is the second half of the review from Chapter 11, so we will be doing sections 11.4 through 11.7. And let's get started here with sections 11.4 and 5, which was the volume of prisms and cylinders. And on these problems we have already we've already identified our base, found the height of our prism, found our lateral area, found the area of our base, and found our surface area. So at this point, volume is really simple. So we know that for a prism, the volume is simply the area of the base times the height of the prism. We identified our base as a rectangle. We found the area of our base to be 12 feet squared, and the height of our prism was right here, and that is 6 feet. So we found our volume to be 72 feet cubed. Volume's super easy. Our next prism here, we had a triangular prism, but that makes no difference. The volume of our prism is still the area of the base times the height of the prism. We had a right triangular base, which makes everything easy, means we already have a base and a height. We found the area of our base to be 60 centimeters, and the height of our prism, base to base, was 9 centimeters. So the volume of our triangular prism is 540 centimeters cubed. Don't forget, volume is always cubed. Area is squared, volume is cubed. All right, our salt container, our word problem here, our salt came in a cylindrical container, and the height of which was 13.5 centimeters. And so we need to find volume. Volume of a cylinder is always area of the base, pi r squared, times the height of the prism, so pi r squared h. So we simply put in our radius, which was 4 centimeters, square that. The height of our prism was 13.5 centimeters. And so we get the volume of our cylinder to be 216 pi centimeters cubed. And if we put that into our calculator, 678.6 centimeters cubed. So we know that the lateral area for design was 339.3 centimeters squared. The surface area for the paper to make the entire container was 439.8 centimeters cubed. And how much salt can we put in it? 678.6 centimeters cubed. So lots of math goes into your everyday products. All right, the same thing is going to be true here for our pyramids and cones. We have already identified our bases. We have found our slant height, because that was what we need to find lateral area. So we may or may not have to do a little extra work on these, because volume is 1/3 times the area of the base times the height of the prism. So if we look here on our first one, we are given slant height. So we have to find the actual height of the prism. We need this dimension right here. But luckily for us, it is a nice right triangle. We are looking for height. We know our slant height was 7, and the length of half of the base is 4. So we can use Pythagorean theorem. A squared plus b squared equals c squared. Hypotenuse is always c, so h squared plus 4 squared equals 7 squared. 16, 49, subtract 16 from both sides. H squared equals 53. No, 33. And then what do? We square root both sides, so we know the height of our pyramid is the square root of 33 centimeters. Now it's not a perfect square, so we can just leave it as is. And now we can find our volume. The volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. So 1/3, we already know the area of the base was 64 centimeters squared, and the height of our pyramid is the square root of 33 centimeters. Our calculator does a wonderful job with this. If we wanted to leave it in radical form, we could do 64 divided by 3 square root 33, or better, to put that into your calculator, 122.6 centimeters cubed. All right, our hexagonal pyramid. On this one, we're already given the height of our pyramid. Right here is 6 centimeters. So that is really nice. That'll make volume really easy. To find our slant height, we had to use Pythagorean theorem, but volume is already set for us. So the volume of any pyramid is always 1/3 times the area of the base times the height. Now, if we wanted this in simplest radical form, our area of our base up here was 6 square root 3, and our height was 6 centimeters. So we could have done this one as, if we wanted simplest radical form, let's see, 36 divided by 3 would be 12 square root 3. And if we put that into our calculator, we get 20.8 centimeters cubed. And we use our radical area of the base so that we don't have rounding errors. All right, and our cone, we are given the slant height of the cone. We want to find the height of the cone. So yes, once again, we are going to have to do a little bit of Pythagorean theorem, but that's okay. We want to find our height here, and our radius we know is 4. So we can do h squared plus 4 squared equals our hypotenuse squared, which is 10 squared. So h squared plus 16, 100, subtract 16 from both sides. H squared equals 84. So we then go square root. So h equals the square root of 84. And now we can simplify 84, the square root of 4 times the square root of 21. So this would equal 2 square root 21 inches. Let's write that over here a little bit better. So our height equals 2 square root 21 inches. Now, a cone, to find the volume of a cone has its own special formula. It's still the same formula, 1/3 times the area of the base, which is pi r squared, times the height of our cone. And so we simply put our numbers in. 1/3 times pi, our radius squared is 4 squared, and the height is 2 square root 21. And so what we end up with is the volume of our cone is 32 square root 21 over 3 pi. If we wanted it in terms of pi, that doesn't look like a very friendly number, so let's do it to the nearest tenth, 153.6 inches cubed. All right. (11.6) was on spheres, surface area and volume of spheres. Spheres have their own formulas. They are based solely on the radius of the figure. Surface area is 4 pi r squared. Volume is 4/3 pi r cubed. So let's look at our first problem here. A spherical beach ball has a diameter of 1.75 feet. So that means we have a radius of 0.875 feet. We just took our diameter divided by 2. We want to know the surface area of the beach ball. So how much plastic does it take to make it? And how many cubic feet of air does it contain? That's our volume. That's a volume problem. So we need to find the surface area of our sphere. It's 4 pi r squared. We simply plug in our numbers. 0.875 squared. And so surface area in terms of pi would be 3.0625 pi, 3.1, or put that into our calculator, 9.62 feet squared of plastic to make the beach ball. It's a lot more than you would think for a relatively small beach ball. All right, and volume is just as easy, 4/3 pi r cubed. We simply substitute in 4/3 times pi times 0.875 cubed. And so volume, if we wanted it in terms of pi, we just multiply and divide all of our numbers, cube our radius times 4 divided by 3, we would get 0.89 pi. Put that into our calculator, we would get 2.81 feet cubed of air. The next problem asks us to find the circumference and volume of a sphere in terms of pi if your surface area is 64 pi meters cubed. So we need to start out with surface area is 4 pi r squared. We know that all of these are related by the radius, so I'm just going to substitute in. I am given surface area, which is 64 pi. Don't forget your pi. And 4 pi r squared. I'm just going to get r by itself, divide by 4 pi on both sides. It's really nice because my pi's cancel there. And so everything cancels over here. So r squared is 64 divided by 4, which is 16. I square root both sides. This is a nice perfect square, so the radius is 4 meters. Now that's going to let me find everything. I want circumference. We know circumference is 2 pi r. So I substitute in 2 pi, my radius is 4. So my circumference is 8 pi meters. We were asked to find things in terms of pi. We get a decimal if we wanted to plug it into our calculator. In terms of pi, that means all our answers are going to be in pi. And we want volume. Volume of a sphere, 4/3 pi r cubed. Again, just substitute in. We have radius, so 4 cubed. Volume, 4 cubed, 64 times 4, 256 divided by 3 pi meters cubed. So there it is in terms of pi. Not a very nice number, so if we wanted volume, we could do 85.3 pi meters cubed would be to the nearest tenth. And if we wanted to go back and look at our circumference to the nearest tenth, that would be 25.1 meters for our circumference. Doesn't hurt to find it in all ways. All right, what's our next problem? So we want to find the surface area of a sphere to the nearest tenth if our volume equals 190 inches cubed. So we know the volume of a sphere is 4/3 pi r cubed. And then we're just going to substitute in what we know. You always write your formula and then substitute in. So 190 equals 4/3 pi r cubed. And then we want to get r by itself. So I'm going to multiply both sides by 3/4. That'll cancel this out. So this is times 3/4. And then I'm going to divide both sides by pi. So divide by pi. And I'm going to remember that this 4 pi needs to be in parentheses down here. And I am going to end up with r cubed equals, if I multiply all my numbers together, 3 times 190 divided by 4 pi, don't forget your parentheses, that equals 142 over pi, 142.5 over pi, and I like to get all my numbers together. And then I'm going to cube root. Don't forget we've got r cubed. So r is going to equal the cube root of 142.5 over pi, or we can write this in using exponents, 142.5 over pi to the 1/3, because exponents are really nice to use. Now we need to do surface area. Since we have our radius, surface area is just 4 pi r squared. And so I'm going to substitute in 4 times pi. Now my radius is 142.5 over pi to the 1/3, or the cube root, however you choose to do it. And then I need to square that. And so now I have 4 pi, and I can put my exponents together, 142.5 over pi to the 2/3 exponent. Don't forget that on your calculator this is up hat, and use your parentheses, 2 divided by 3. Or you could also use your cube root, and that would look like the cube root of 142.5 over pi squared. Your calculator will know how to do it like that as well. And then I do just put it all into the calculator. It knows how to deal with exponents and pi's and roots and cube roots and squares, and we get 159.8 inches squared. So those can be a little bit challenging. Be careful with your cube rooting and your squaring and your square rooting and your cubing. Be very careful, show all your steps, and keep track of it all. Moving on to lesson 11.7. This was similar figures and their ratios. And we are asked, are the two figures similar? If so, give the similarity ratio, that would be scale factor, perimeter ratio, area ratio, and the volume ratio. And we are told smaller figure to larger figure. So here's the small, here's the large. So we first need to decide, are the two figures similar? Well, I need to compare all of their lengths. So we have 6, 6, 4, and 3, 2, 3. I am going to say the best bet here is to start with the small pieces and do a 2 to 4, which reduces to 1 to 2. And then I'm going to look at this side. So that is a 3 to 6. I remember I'm doing small to large. So 3 to 6 is a 1 to 2. Looking good so far. And this last side here and this last side here, we have a 3 to 6, which gives us a 1 to 2. So yes, they are similar because all of their sides are proportional. All of their length measurements are proportional. So we know that we have a scale factor of 1 to 2, small to large, scale factor of 1 to 2. And if you remember back long ago, we said that our perimeter ratio is just the same as the scale factor. So our perimeter ratio is also 1 to 2, small to large figure. Now, we also learned long ago that our area ratio is just our scale squared. So that's 1 squared over 2 squared. So our area ratio is 1 to 4, which should make sense to you. And our newest thing was our volume ratio is our scale cubed, 1 cubed over 2 cubed. So volume is a 1 to 8 ratio. So now what this says is that every time we increase the area, the larger one gets 4 times bigger than the smaller one. And every time we increase the volume, the larger one is 8 times bigger than the small one. So volume increases quickly. It's that whole cubed thing. All right, now we get some practice with our square roots and cube roots and all of that good stuff. We are given two similar figures. Find the missing surface area or volume and round to the nearest tenth. So we know when we do these problems, number one, we find the scale factor. No matter what you're given, you have to get to scale first. And then number two, we find the new ratio. So if we're looking for area or volume or whatever we need to find our new ratio. And then step 3, we write a proportion to get what we need. So we have a small figure and a large figure. And our first problem here compares the surface area. So we know that we have an area ratio of 121 to 196. So how do I find my scale? Well, scale, we know, is the square root of your area ratio. And so our scale, these are nice perfect squares, our scale is an 11 to 14 ratio. So we have found our scale. Now we need the scale to get us to volume. That is what we are actually trying to find here. So we need to, number 2, find our new ratio. We want the volume ratio. We know that our volume ratio is our scale cubed. So I'm going to find my new ratio here, 1331 over 2744. And then I'm going to use that to write a proportion. I know that 1331, 2744, and small to large, you can write that in if you need help remembering that. We know the large volume, so that's going to go down here on the bottom. And what are we looking for? The volume of the small figure. So now it's a simple matter of cross multiply and do opposite operations, or we could just simply times by 343 on both sides. Either way, we end up with the volume of the small figure is 166.4, and our unit is centimeters cubed. So easy enough. All right, let's look at the next problem. This time we are given the volume ratio. So we know that our volume ratio is 307.2 to 600. And what do we need to do first? We need to use that to find scale. How do we find scale? Well, we know that we need the cube root of 307.2 over the cube root of 600. And I can tell you right now, these are not perfect cubes. So we are just going to leave them either like this or using our exponents. Cube root means it's raised to the 1/3 power. So we can use either one of these as our scale. And so now we need to find our new ratio. Well, what are we looking for? We're looking for surface area. And what do we know about our area ratio? Our area ratio is our scale squared. So we can either do the cube root of 307.2 and then square that over the cube root of 600 and square that. Your calculator knows how that is, knows what to do with that. You can put it in exactly like that. Or we can use our exponents and do 307.2 to the 1/3 and square it. Same way with our 600 to the 1/3 and square it. And a power to a power, you multiply. So 307.2 to the 2/3 power and 600 to the 2/3 power. Either one of these works very nicely. I prefer using exponents, so that's how we're going to do this. So I now have my new ratio. I have my area ratio. Now I am going to write a proportion. So here's my proportion. I am putting small on top, large on the bottom. And we get 307.2 to the 2/3 over 600 to the 2/3. And what are we given? We are given the volume of the large. No, surface area of the small, 160, and so we are looking for surface area large. And then we are simply going to cross multiply, and then opposite operations. If you remember your proportion rules, we can just switch those two and end up surface area of the large now goes on top. Right, and then on this side I have 160 divided by 600 to the 2. Not true. Sorry about that. 160, the 307 comes down here to the bottom because I switched the sides. 307.2 to the 2/3, and then I'm going to multiply up on top here my 600 to the 2/3. That's just opposite operations. Took it from the bottom, multiplied it on the top, and we are going to get surface area of our large figure. Put all of that into your calculator, and entertainingly enough, it comes out to be 250 feet squared. So be careful with these. That is chapter 11. The hardest part of this is your squares and your cubes and your square roots and your cube roots. Just keep track of all of them and use your parentheses in your calculator, and your calculator knows how to do these very easily. I'm sure you will do fine.